Sessions 5.1 Meaning of probability. Probability of an outcome from a random experiment is a relative frequency of the outcomes if the experiment were run an infinite number of times. So what is a random experiment? When we call a process that selects the items randomly, this is called a random experiment. For example, we could flipping a coin or rolling the die. Both of the events are called random experiment. And we have the sample space of the random experiment is the group of all possible outcomes. For example, if I flip the coins, I only can get head or tails. So head and tails, we call this is gonna be our sample space. An event. An event is sum of the outcomes in the sample space, all of them or none of them. So this is means like if I flip the coin, I want to get the head. So getting the head is the event in the sample space in here. Okay, look at the example, finding the probabilities. An experiment consists of rolling a six-sided die from number 1 to 6. Once, find and interpret the probability of rolling a 4. So I have a six-sided die. First, write it down what is the sample space. Remember, sample space means what outcomes you can get when you roll this die. You could see sample space, we could get either 1, 2, 3, 4, 5, or 6. And then what is my event in this example? I want to get a 4, okay? Getting a 4. So my event will be rolling a six-sided die with 4. So what is probability to get the 4 if I only roll the die once? So you could see the answer is going to be 1 over 6 because we only have a 1, 4 from here out of 6 possible outcomes. So that's going to be 1 over 6. Okay, so think about it. I got like P of 4 equal to 1 over 6. Does it means if I roll the die like 6 times, okay, 6 times, I should get 1 4 from there? May not be, right? I may get like no 4 at all. I may get like more than 1 4 in here. So the probability of 4 equal to 1 over 6, this is talking about if we roll the die like infinite number of times. Means I keep rolling on it, and write it down the result. We could get a 4 exactly 1 over 6 of the time. Okay, I could roll the die like 600 times. I may get like 100 times is gonna be equal to the 4 in here. Of course, we will try to roll the die in a large number of times. 600 is still a small number. We may want to roll it like 6,000 or 60,000 of times. So we could get the result that will be really, really close to 1 over 6 of the time. Okay, formula. If the sample space of a random experiment consists of n equally likely outcomes, and an event E consists of m of those outcomes, then you will have the formula here. This is called the basic probability. The event that you want to get equal to consists of m of those outcomes over the n, and here is talking about the total outcomes. I will write it, I would say P of E equal to the favorable E. How many results going to be favorable to the E? Over the total outcome. So you're going to count for your sample space, how many outcomes do you have? So you could just apply it in here. I have 6 outcomes. Okay, total outcome is going to be equal to 6. I only have a 1 favorable 4 here. So that's why it's going to be 1 over 6. So in other words, if the sample space of a random experiment consists of finite number of equally likely outcome means When I roll the die is a fair die. They should have the same probability to get on each number. Then the probability of the event is equal to the number of the outcomes in the event divided by the number of the outcomes in the sample space. Okay, so this is just talking about the formula from here. Okay, example, calculating probabilities. For a group of 10 students in one of the Alpha's algebra class, there are 2 nursing major, 4 business major, 1 architect major, and 3 undesign majors. None of the students are double majors. And assume one student is randomly selected from the group. Use N for nursing, B for business, A for architect, and U for undesign. So when you guys find out P of N, okay, the probability to get the nursing students. So we'll be using this formula, the basic probability. First, how many students are major in nursing? So we do have 2 students, they are major in nursing, right? And then total outcome, how many total students do we have in here? You could add it up here, or they already tell you for a group of 10 students. So that will be 2 over 10, which is going to be 0.2. Construct a frequency and relative frequency table for the students' majors. So we have the frequency distribution, and I list all the majors from here. So fill in frequency, how many students are major in nursing. So we have 2, so put the 2 in here. And then find out the relative frequency. Remember how to find the relative frequency? Use the frequency divided by the total number of the frequency. We know we have 10 students for total. So 2 divided by 10, which is going to be 0.2. Okay, now try to finish this chart here. Okay, check your work. You do have 4 business major, 1 architect, and 3 undesign. Then calculate the relative frequency. Okay, add it up, find out the total. You do have 10 students. Remember, what is the sum of all relative frequency equal to? It should be equal to 1, right? Or really close to 1 here. Okay, so look at the frequency distribution and with the question number 1 here. If we want to find the probability for nursing, okay, P of N, that will be equal to 0.2, which is going to be equal to your relative frequency. Okay, they should be equal to each other in here. So now I want you guys find out probability of business, probability of architect, and probability of undesign. Okay, probability of business, so that will be 0.4. Architect, 0.1. Undesign, that will be 0.3 here. Okay, number 4. Find the probability of the students major in philosophy. Okay, so look at here. Any students major in the philosophy? No, right? So I only have 10 students here and no one's gonna be major in philosophy. Now I'm gonna close my eyes and I try to pick one student. and I want to know what is the probability that the student is a philosophy major. Is it possible? No, right? So using the formula, that will be 0 over 10. We do have a 10 students for total, but no one's going to be major in philosophy. So that will be equal to 0. It is impossible. Okay, number 5, find the probability of randomly select in nursing, business, architect, or undecided. So means like I'm gonna close my eyes. I want to pick one students. They are in these major or. Okay, so which is gonna be the event consists of the total number of the students here out of 10 students. It's gonna be 1. Okay, number 6. Find the probability of nursing plus business plus the architect and a undecided. So meaning like we want to add it all up from here. That will be equal to 1, right? Why does the result make sense? Because we know that sum of all the relative frequency has to be equal to 1 in here. Okay, so this doesn't make sense. We just add up all the relative frequency together, and which we're gonna know it has to be equal to 1. Probabilities properties. So probability of an impossible event is going to be equal to 0. Okay, we just saw this one for the previous example. Or you could think about it, what is the probability that getting head and tail if I flip the coin once? Is it possible if I only flip the coin once, I could get the head and tail? No way I could do that, right? So we say the probability to get head and tail, that will be equal to 0. Probability of a sure event is equal to 1. What is probability that getting head or tail? If I flip the coin once, I want to get either head or tail. For sure, I'm gonna get head or tail, right? Because I only have 2 outcomes. So probability is gonna be equal to 1 in here. And then probability of an event is between 0 and 1. Okay, so make sure you guys remember that every time when they look for the probability, you have to find the answer between 0 and 1. Okay, between 0 and 1. If you got greater than 1 or less than 0, means you make a mistake. Sum of the all probabilities of all the single outcomes event in the sample space is going to be equal to 1. So for example, when I flip the coin once, I'm going to get the head. When I flip the coins one more time, I'm going to get the tail. Right? When I add it up, these two guys has to be equal to 1. Okay, using a pie chart to find probabilities. The pie chart in the figure describes the percentage of 1,445 online adults who use various numbers of social media websites. Find the probability that a person randomly selected from the survey use exactly 3 sites. Exactly 3 sites is gonna be here. Okay, so 12%. And we could use the relative frequency, which is gonna be equal to 0.12, right? Or 0.12. And you know that probability will be equal to the relative frequency. So that will be equal to 0.12. Okay, B, at least 3 sites. At least means 3 or greater. So at least 3 means 3 or 4 or 5. Okay, so I have 3 or 4 or 5. So we could just add up these three numbers together. That will be 19%. Write it down, so probability will be equal to 0.19. And then C, at most 3 sites. At most means 3 or less, right? So that will be including 0, 1, 2, or 3. Okay, 0 means the no sites here, 0, 1, or 2, or 3. So add up these four numbers, you could get 93%. So which is going to be 0.93. From inspecting the pie chart, students conclude that 36% of all Americans use just one site. What could you tell the students? So based on the numbers here, only use one site is 36%. The students is correct, right? But think about it. We cannot conclude that 36% of all Americans use just one site. This is the online survey and may not be represent all the online adults well and represent all the Americans. Okay, random variable. A random variable is a numerical measure of an outcome from a random experiment. We often use a capital letter such as X to stand for the random variable. So random variable is a numerical measure, so which just means it will present the number. Look at this example here. Let X be the outcome of rolling a 6-sided die once. Find the given probability. Okay, so now we're going to roll the die once. Find the probability of X equal to 4. So again, sample space to roll the die once, we could get 1, 2, 3, 4, 5, 6. And we only have a 1, 4 here. So that will be 1 over 6. And X less than or equal to 4. X less than or equal to 4, this is means I want to find the probability equal to 1 or 2 or 3. Okay, X is less than or equal to 4 means X is going to be equal to 1 or 2 or 3 or 4. Okay, again, sample space is going to be from 1 to 6. We have a 6 total outcome. And I want to get this 4 number, so that will be 4 over 6, which is going to be 0.67. Number 3, X greater than 4. Okay, X greater than 4. So greater than 4 means like X equal to 5 or X equal to 6. And we only have a 1, 5, and 1, 6 out of 6 outcome. So it's going to be 2 over 6, which is going to be 0.33. Last one. The X has to be between 3 and 6. So this just means we are looking for the X equal to 3, 4, 5, and 6. So that will be 4 out of 6 number, which is going to be 0.67. That's it for the session 5.1.